Hi, grade 10. Today we're doing lesson 6.3 and 6.4, which is Sine Law, and there's a handout on Teams that you should print out and fill in as you watch this video. So at the top of the handout there, it says, there's a box and it says key ideas. The first point says, using Sohcahtoa, which can only be used for right triangles, we can develop the Sine Law, which can be used to find missing angles or side lengths from any triangle. So now we're going to be able to solve triangles that are not 90 degrees. So first we're going to start by proving the sine law, so you can see where it comes from. So there is a triangle drawn on your page, triangle ABC. And I'm going to label each opposite side length as the lowercase version of the angle across from it. So side length A is opposite angle A, side length B is opposite angle B, and so on. And then the height I'll label as H. And this forms two 90-degree angles. So looking at these two triangles separately, I am going to use Sohcahtoa to come up with an expression for the height for both angle A and angle B. So sine A equals, using Sohcahtoa, sine is opposite over hypotenuse. So the side length that's opposite angle A would be H, and the side length that's the hypotenuse for angle A would be B, because it's opposite the 90-degree angle. In order to get H by itself, I would need to multiply both sides by B. These ones would cancel out, and now I have an expression for H. I have B times sine A equals H. I'm going to do the same thing for angle B, looking at this triangle here. Sine B equals, again, opposite over hypotenuse. So the side length that's opposite B is H, the height, and the hypotenuse is A, which is opposite the 90-degree angle. In order to get H by itself, I'll need to multiply both sides by A. This side will cancel out, and now I have an expression for H, which is A sine B equals H. Now, in order to prove the sine law, I'm going to use substitution to put these two equations together. So H equals H, and they both equal H, so therefore the two equations will equal each other. So that means B sine A equals A sine B. And now I have two options for how I can simplify this. So the first option, B sine A equals A sine B. In this case, I'm going to divide both sides by lowercase b to start. Now that will cancel out on the left side, the b's, and then I would like to get rid of the a from the right side, so I'm going to divide both sides by lowercase a. So on the right side, the a's will cancel out, and I am left with sine A over A equals sine B over B. So this is one way to write the sine law. Option 2, again, I start with B sine A equals A sine B. But this time, instead of dividing by lowercase a and b, I'm going to divide both sides by sine A, which will cancel out the sine A on the left side. And then I'm going to divide both sides by sine B, which will cancel out the sine B on the right side. And now I'm left with B over sine B equals A over sine A. And this is another way to write the sine law. So we can either have the sine A and sine B on the top and the lowercase a and b on the bottom, or we can flip the entire thing where the lowercase a and b are on the top and the sine A and B are on the bottom. But we need to make sure that we always keep the signs together on the top or together on the bottom, and the lowercase letters together on the top or together on the bottom. Okay? And this process can also be repeated for angle C. So the sine law can be written as sine A over A equals sine B over B equals sine C over C, or B over sine B equals A over sine A equals C over sine C. And that's what you can write there for the next bullet in the box, where it says the three ratios of the sine law can be inverted. So you can either have the signs on the top and the lowercase letters on the bottom, or you can have the lowercase letters on the top and the signs on the bottom. And you will see, as we do problems, you'll see which situation you should do which for. The next point says, when trying to find a missing side or angle, use a ratio that has 3 knowns and 1 unknown, and then cross multiply and divide. So when you're solving problems, you will only need to use 2 of the 3 fractions or ratios in your problem. So you'll pick 2 that apply to the problem, and then you'll fill in the missing parts. So you will need to know 3 of the 4 sections in order to solve for the 4th section. All right, example number 1. Find the missing side lengths and angles in each triangle. So we'll start by drawing the triangle. This is triangle PQR. I know angle Q is 39 degrees. Side length PQ is 41, and side length PR is 28. Now I'm going to label the sides as the lowercase letter of the angle they're opposite to. So this would be side length P, this would be side length Q, and this would be side length R. Okay, so then you know which one we're talking about. So since angle Q equals 39 degrees and side length Q equals 28, that's a complete ratio. So we can for sure use sine Q over Q. And since R equals 41, that means we can solve for angle R because it can be our unknown. So we're going to write sine R over R equals sine Q over Q. So this is just the same as the sine law here, but instead of using A, B, and C, this was triangle PQR, so we're using PQ and R. So notice that I put sine R on the top here. I did that on purpose. Instead of putting the lowercase letters on the top, I put the angles on the top because that's the one I'm missing. And it's easier to solve if you put the missing one on the top. It will work if you put it on the bottom. It's just going to be more rearranging and more steps to get there. So if you think of it, put the missing one on the top. Okay? All right, so we're going to fill in what we know. So we don't know sine R. And then R is 41. Sine Q is, angle Q is 39. So sine 39 over Q is 28. Now we're going to solve for the missing part of this ratio. So we want to get sine R by itself. So right now, sine R is being divided by 41, so we're going to do the opposite of that, which is multiply it by 41 on both sides. So the 41s will cancel out on the left side, and I will have sine R equals 41 times sine 39 over 28. So notice how I put the 41 in front of the sine 39? That's the way we normally write it when we multiply something by sine, cos, or tan. And it's just because it's the simplest way. We don't need to use any brackets. The 39 and the 41 aren't beside each other. They're not getting confused. So we put the number we're multiplying by in front. Okay, so now we have sine R equals all of that. We need to find what angle R is. So when we're missing the angle, we need to use sine inverse. So R equals sine inverse bracket 41 sine 39 divided by 28. And now you're going to type all of that into your calculator using the brackets in the appropriate place, and you should get 67 degrees. If you typed that all in and you didn't get 67, you need to double check that your calculator is in degrees. And if you're having trouble with that, you can send me a message and I'll help you fix it. Okay, so far we have found angle R, which is 67. Next, we can find angle P. Since the interior angles of a triangle always add up to 180 degrees, we know two of them, so we can find the third one. we'll do 180 degrees minus 39 minus 67. And that gives us 74. So angle P is 74 degrees. Okay, and now all we need to do is find side length P. So we can either use the ratio of R's or the ratio of Q's because they're both complete ratios. Either one will give you the right answer. So we're going to use Q's in this case. We need to find lowercase p, so we're going to put that on the top. P over sine P equals Q over sine Q. We don't know P, so we're going to just write P. Sine P is sine 74 equals Q is 28 and sine Q is sine 39. We need to solve for P. Right now P is being divided by sine 74, so we're going to do the opposite of dividing, which is multiplying by sine 74 on both sides. And now we'll have P equals, these ones will cancel out, 28 sine 74 divided by sine 39. And type all of that into your calculator and you should get 43. And that's the side length 43, so that would be like in centimeters or meters or that sort of thing. Okay, on to number 2. Okay, so again, we're going to solve for the missing angles and side lengths. This is triangle ABC. We'll also label the side lengths ABC as lowercase. We know angle C is 63 degrees. Side length B is 4.7. And side length C is 5.5. All right, so we're going to start by finding angle B because we know side length B. So that's part of the ratio that we know. So we're going to do sine B over B equals, and then the other complete ratio that we know is C. So we'll do sine C over C. So notice how I put the missing thing on the top again. Sine B was the part we're missing, and I put that on the top so it's easier to solve. So let's fill in what we know. So we don't know sine B. B is 4.7. Sine C is sine 63. And C is 5.5. So we want to get sine B by itself. So right now it's being divided by 4.7. So we're going to multiply both sides by 4.7. It will cancel out on the left side, which will leave us with sine B equals 4.7 sine 63 over 5.5. Now we have sine B. We're missing the angle, so we need to use the inverse of sine. So B equals sine inverse bracket 4.7 sine 63 divided by 5.5. Type all of that into your calculator using those brackets, and you will get 50 degrees. So now we know angle B is 50 degrees. Now, again, we can find angle A just by using the fact that the interior angles of a triangle add up to 180 degrees. So 180 minus 50 minus 63 equals 67 degrees. So angle A is 67. Okay, so now we just need to find side A. Side A, we can either use the ratio of the B's or the C's because they're both complete. They'll both give us the right answer. Let's use B in this case. So we're missing A, and we have sine A over equals B over sine B. So A over sine 67 equals B is 4.7 over sine B is sine 50. we want to get A by itself, so it's being divided by sine 67, so we'll multiply by sine 67. This will cancel out on the left side, and then we'll have A equals 4.7 sine 67 divided by sine 50. Type that all into your calculator and you will get A equals 5.6. So side A is 5.6. Okay, number 3. Emily needs to paint a triangle on the grass for an activity outside. She has been given the following instructions. Angle X equals 32, angle Z equals 57, and XY equals 41 meters. What will the perimeter of the painted triangle be? So let's start with the diagram. X, Y, Z. Angle X is 32 degrees. Angle Z is 57 degrees. And XY is 41. Let's label the side lengths with the lowercase letters. So opposite of angle Y will be lowercase y, opposite angle X will be lowercase x, and opposite angle Z will be lowercase z. So first we're going to find the missing angle, and then we'll find the missing sides and add them together to find the perimeter. So the missing angle is Y. So since triangles add up to 180 degrees, we can do 180 minus 32 minus 57. So angle Y is 91 degrees. Okay, now that we know that, I'll label it. We can use sine law to find the missing side length. So let's start with finding side Y. So Y over sine Y equals Z over sine Z, because that's the other complete ratio. We don't know why. Sine Y is sine 91, Z is 41, and sine Z is sine 57. Now in order to isolate Y, we will need to multiply both sides by sine 91. They'll cancel out on the left side, so we'll have Y equals 41 times sine 91 divided by sine 57. Type that whole thing into your calculator and you will get 48.9 meters. Okay, now we just need to find X. We'll use sine law again. X over sine X equals Z over sine Z. We could use the ratio of Y over sine Y as well, because we have that whole one, but we'll use Z in this case. So we don't know X. Sine X is sine 32. Z is 41, and sine Z is sine 57. We need to solve for X, so we'll multiply both sides by sine 32. This will cancel out on the left side. So X equals 41 sine 32 over sine 57. Type that all into your calculator, and X equals 25.9 meters. Okay, so now we have all the side lengths. Now we need to add them all together to find the perimeter. So perimeter equals 41, which was Z, plus Y is 48.9, plus X is 25.9. And that's a total of 115.8 meters. Okay, on to number 4. You came across a gorgeous waterfall on a hike through a forest and were curious about how high the waterfall was. Since you had a clinometer with you, you measured the angle of elevation from 2 different locations that are 5 meters apart. The angle was 67 degrees from one location and 23 degrees from the other. How high is the waterfall? So first we'll start with what's a clinometer. Well, according to Google, it's a tool used to measure the angle of elevation or the angle from the ground. And it was super handy. You just happened to have that along with you and you really wanted to know how high this waterfall was. So you just casually measured the angle of elevation, and we're going to now calculate the height of the waterfall. So let's start with the diagram. There's your waterfall. At the top of the waterfall, we'll label that as point A. Now, you measured from one point and it was 67 degrees. And then you moved over 5 meters and measured again, and this time it was 23 degrees. Now I'm just going to draw a right triangle here. So this is the waterfall, and then the bottom is the ground. So I don't have enough information to use Sohcahtoa to find the height of the waterfall yet. So I'm going to need to use this skinny triangle here to find the length of this length, which I'm going to call C. Once I find the length of C, I'll be able to find the height over here. So I'm going to label the skinny triangle as triangle ABC, and then the side lengths as the lowercase letters opposite. So this 5 meters would be side length A, B, and C. So first of all, I can start by calculating angle B on the inside of this triangle here. This full distance here would be 180 degrees. So angle B right there would be 180 minus 67. And that's 113. So we'll start with that. Then I am able to calculate angle A as well, because all three angles in the triangle would equal 180. So 180 minus 113 minus 23, and that means angle A is 44 degrees up here. So since we have the angle A is 44 degrees, and we know that side A is 5 meters, that's a complete ratio. And we know angle C is 23 degrees, so then we can solve for side C, which we need in order to make this right triangle work. So let's set up that ratio to start. So C over sine C equals A over sine A. C we don't know. Sine C is sine 23. A is 5. And sine A is sine 44. So I'd like to solve for C. So I need to multiply both sides by sine 23. This will cancel out on the left side. So I'll have C equals 5 sine 23 divided by sine 44. Type all of that into my calculator, and C equals 2.8 meters. Okay, so now I'm going to take this triangle here and redraw it on the next page. So I have my waterfall. This is point A. This is 67 degrees. Side C we said was 2.8. And we'll call this the height. Oh, sorry, that was angle B here. Okay, so now we have enough information that we can use Sohcahtoa instead of the Sine Law to solve for the height. So I'll write down Sohcahtoa so we remember it. So we are talking about angle B here because that's the one we know, and we need to find the height. So the height is opposite it. So we have angle B, we have the opposite, and we have the hypotenuse. So using that information, opposite and the hypotenuse, we're going to use sine, because sine equals opposite over hypotenuse. So we're going to do sine B equals opposite over hypotenuse. So in this case, the opposite side is the height, and the hypotenuse is 2.8. And angle B is 67 degrees, so I can write that in for B. So sine 67 equals h over 2.8. I want to solve for h, so I'm going to multiply both sides by 2.8. It will cancel out on the right side, So now h equals 2.8 times sine 67, typed into your calculator, and that's 2.6 meters. So therefore, the waterfall is 2.6 meters tall. All right, that wraps up the lesson. So let me know if you have any questions, and have a good day.